Hello everyone. Today we are in the chapter 6 and we will discuss about bandwidth utilization by multiplexing and spectrum spreading. In this section bandwidth utilization you have two broad categories. In one is multiplexing, the goal of efficiency, and then the spectrums. First one is the multiplexing. Multiplexing is a set of technique that allows the simulation of transmission of multiple signals across a single data line. In this section, we have to have the basic idea of the multiplexing by this diagram. In MUX means it is a multiplexing and DMUX is for the demultiplexing. Here we have n input and and we are getting the n input and transform into one single data line with n channels and then send it to the demultiplexer, and then it can have the n number of output. As you can think that this one line is our cable TV channels. Here we have in the TV section we have one wire which is one link, and we have n number of channels which are n channels. So the company or provider is providing you n input lines in one single link, and then your TV demultiplexes it and creates n number of channels by one link. Categories of multiplexing. Here are frequency division multiplexing, wavelength division multiplexing, and time division multiplexing. Here frequency and wavelength are works on analog system, and the time division works on the digital system. Here are the difference between FDM, which is frequency division multiplexing, and TDM, which is time division multiplexing, which is very important for your questions. It is not sensitive, and this is sensitive. The total frequency bands are divided into serial users, but in total available time is divided into serial users. FDM is performed with the analog signal, and this performs with the digital signals. Synchronization is required in TDMA, but synchronize is not required in the FDM. FDM provides less flexibility, whereas TDM provides more. FDM provides much better latency, but TDM provides less latency. Now the difference between links and channels. Links is the cable and channel is the n number of channel in your TV. So links refer as a physical path and the channels refers as a portion. One link can have n number of channels, but the channels cannot have n number of links. This is the physical address, and then this is the physical transmission media. Now the frequency division. In this one link, the channels are divided by frequencies, where channel 1 have a frequency, channel 2 have different frequency, and channel 3 have the different frequencies. Then the ground band. FDM divides the carrier between the logical channel and allocates the one user to the each channel. The channels are specified by the strips. In unused bandwidth is called the ground band, and thus the ground bands provided the signals overlapping. FDM processes. Here are multiplexing process and demultiplexing process. Multiplexing process is used to generate a signal by severals. That means that here we have the modulator and carrier section. Here we are giving the input. Here the input is like this, and here the input is like this. So by modulator and carrier we will generate different signals, and after combining that we will generate a one link. That is the work of the multiplexing processes. The multiplexing processes, it takes several channels and put them into one link, is known as the multiplexing processes. And the demultiplexing processes, it takes the one link and then divided the channels by their frequencies or any other stuff, like which diagram is looks like this. The application of FDM, which is very important, which is used in FM or AM radios. It is also used in television broadcasting and generating cell phone. Cellular telephone are also known for the FDM. Here is a mathematical notation or diagram for the FDM. In here we can see that here we have the line for 0 to 4, 0 to 4, 0 to 4. The modulator divided the channels as 20 to 24 is for this line, 24 to 28 is for this telephone, and 28 to 32 is for this telephone. Those are going in the same link to the destination. Here it is the sender side and this is the receiver side. After receiving the side, this will divide it by their frequencies, where 20 to 24 is for this one, 24 to 28 for this telephone, and 28 to 32 for this telephone. That's how the FDM works, and this function is for multiplexing and this function is for demultiplexing. Now again, here is a mathematical notation for FDM. By this picture you can understand what is ground band. The ground band is the free space between two frequencies. In this FDM section, different inputs have different frequencies, and after combining that, it will send a 1 megahertz section to one link, is known as the multiplexing sections. Wavelength division of multiplexing. Here we have multiplexer and demultiplexer. Here lambda 1, lambda 2 and lambda 3 are wavelengths. Those wavelengths are different from each other. So after multiplexing, we are sending those three wavelengths in the same link, but when it receives to the demultiplexer, by the length of their wavelength, it divided them into three parts, which are lambda 1, lambda 2 and lambda 3, which are wavelength with division multiplexing. The application of WDM is given as the SONET network and FTTC, which stands for fiber to the cable. Time division multiplexing is for dividing the links on and channels by the time division multiplexing. Here the time, when time is 4 3 2 1, and again it is 4 3 2 1, 4 3 2 1, then when the time comes, then it will send the data or channel to this PC. When the 1, it will send to the 1 PC. When it is 2, it will send to the PC 2. When it is 3, it is sent to the PC 3, and for 4, it is sent to the PC 4. TDM have two different types: synchronization of TDM and statical of TDM. In synchronous TDM, it continuously sends data which is divided into packets, is known as synchronous TDM, and when it is generated time slot, means that it will generate frames by times. Here we have frames where we have A, B and C, all the components which are sorted by the time slots. Here it is for time 1, time 2 and time 3. Now we'll discuss about frames. We have already discussed about frame. In this section, the frame will generated by the inputs. Statistical time divisor means that inputs are coming, and here we can see that we have E, then E2, D, then D2, and B, then B2. Here we have statistical sections for time division. E is for the time of E, D is for the time of D. Then after, when the D2 is sent, then the D section will carry the D1. After the B carry the B2s, and then the B section will carry the B1 section, and in A section it have only one data, which is A1, which will be transmitted. This is known as the syntactical TDM. The difference between synchronous and statical TDM is given. Here error control is not possible, but here error control is possible. Channel quality is good, but in this section statistical it is very good. It is flexible and this is not very much flexible. Multi-drop capability is occurred in the synchronous, but multi-drop capability is very much possible in statical TDMA. Those differences are very important for your exam point of view. Have a snap of this one. The previous question I will give the link description below. Please check that one. Thank you for today. Oh wait, we have to discuss about this one, which is modulation and multiplexing. Modulation is used for carrier signals to the sender information, and multiplexing is a way of combination of multiple signals. Modulation is to change the form, that times modulation is to convert from digital to analog or analog to digital, but in multiplexing we don't change the form but combines two or three things and send it in the one line, is known as the multiplexing. So this difference is also very important. Thank you.